Hey guys, welcome back to another nice lectures video. Today is a chemistry one, and today we will be talking about net ionic equations. So what even are net ionic equations? Well, net ionic equations are another way of writing chemical formulas, but they only show the particles that are actually involved in the chemical reaction, meaning that any ions in the reaction that don't do anything, that are not involved in the active combination or reaction, are removed from the net ionic equation to write like a more simplified version. And let's go over how to write net ionic equation. So I've listed out the steps here for you. Step number 1, you need to write the balanced molecular equation. So you need to write like a normal molecular equation with the correct coefficients and the correct states. That's the most important part, is that you have the states and the coefficients. And if you don't know how to write the correct states, well, then you have to go over solubility rules, which might be in a different video. But it's really important to have your correct coefficients in your molecular equations, because that will come out in our net ionic equations. So for an example right here, I just have silver nitrate, AgNO3, which is in an aqueous solution, so it's AQ, plus sodium chlorine, or NaCl, which is another aqueous solution, creates silver chloride, which is in a solid, plus sodium nitrate in an aqueous solution. Now, once you've written your correct balanced molecular equation, as you can see here, it is balanced, it has the correct coefficients and everything. Now, you need to write your ionic equation, not your net ionic equation, just your normal ionic equation. Like, you might be asking, what's the difference? Well, with an ionic equation, you're simply just taking your molecular equation that you wrote earlier and just splitting each and every individual compound up. But there is a catch. You do not split any solid. So if you have a solid in your chemical equation, in your product side usually, you will not split it in your ionic equation when you're writing your ionic equation. Also, one of the big things about ionic equations is that you need to add your charges, because that will come later on. So how my previous example, where I had the silver nitrate plus the NaCl, made the silver chloride, etc., etc., I just simply took all of the ones of my aqueous solutions. I left my silver chloride. Notice here that it's in a solid state. I left that in my ionic equation because you don't split up the solids. But I split up everything else. So here in my silver nitrate, which was an aqueous solution, I split it up into silver, which was in +1 charge, an aqueous state, plus nitrate, which is a -1 charge, also in an aqueous state. And then I did the same thing for my NaCl, which was aqueous. I split it up into Na, which has a charge of +1, aqueous again, plus the Cl, and it creates, and notice here I did not split up my AgCl. That because the reason I didn't split up my sodium chloride is because it's in a solid state. Again, you do not split up the solid states, and that's usually one of the big mistakes that a lot of students make, is that they split up the solids, and then it messes up the whole net ionic equation. But notice here, when I had my sodium nitrate, which was in aqueous, I did also split it up. And also, my original equation, this is seen as a double replacement equation, correct? Meaning that in my products, I'm always going to have one aqueous product and then one either solid, liquid, or gas product. And again, you can tell that by your solubility rules. Now, your next step after you've written your ionic equation is to cancel your quote-unquote spectator ions. What are spectator ions? They are the ions that are not involved in any chemical combining or product or reaction or anything. They are just the ions that appear on both sides. So notice here, I have Ag plus NO3 plus Na plus Cl makes AgCl plus Na plus NO3. So here I see an Na repeating on both sides, and I see an NO3 repeating on both sides, meaning that these are called the spectator ions, meaning that I can just cancel them out from my ionic equation. Cancel out the NO3 here and NO3 here, cancel out the Na here and the Na here, and then whatever I'm left with, I'm just left with Ag plus Cl makes AgCl. So that's how you write your net ionic equation. It's just whatever remains after you cancel out the repeating ones. So whatever remained, Ag plus Cl equals AgCl. It's that simple. Now let's do some practice. Okay, so I have this question right here where it says lead nitrate, so PbNO3 2, which is an aqueous solution, plus potassium iodide, which is also aqueous, creates what? Okay, well, my first step as I go back to my steps is to write the balanced molecular equation. Okay, so I don't have any products, so I'm going to write my products. Here I see that I have a double replacement reaction happening because the positive lead in the negative nitrate and the cation of potassium in the anion of iodide, meaning that the positive lead will take the negative negative iodine, and then the negative nitrate will take the positive potassium. So now let's write on our product side. So I know that Pb takes Pb, which is the anion, which has a charge of +2, will take the iodide, which is the charge of -1, and so then that will make PbI2 plus KNO3. Now I'm gonna just balance my equations. I need to have 2 KNO3s and then add a 2 right here, and there, it is balanced. Now we need to decide the states of these products. Well, from my solubility rules, I know that lead iodide is insoluble because it includes lead, which is an exception to a lot of rules, so which means that this is as a solid, which will be a precipitate in the solution, and then potassium nitrate is usually an aqueous solution because nitrates are usually soluble based on your solubility rules. Now our next step is to write the complete ionic equation. Now I'm going to just split up everything that I wrote. So I'm gonna write Pb plus 2, and then this is in an aqueous state, plus 2 NO3, because here our NO3 has a subscript of 2, meaning that any subscripts always get turned into coefficients in your ionic equation, plus 2 potassium, which is at a charge of +1. Oh, this was at negative charge, aqueous, and then also aqueous, plus, again, 2 iodines, which have charges of -1 and are also aqueous. Then create, and then lead iodide does not get broken down because it is a solid. So I'm going to leave lead iodide as PbI2S, and then plus 2 potassium negative aqueous plus NO3 negative, 2 NO3s. 2 NO3 negative aqueous. Okay, this is your ionic equation. This is your ionic equation, but it is not your net ionic equation. What do you need to do for your net ionic equation? You need to cancel out the spectator ions. So what do I see here that is being repeated? I see there's 2 NO3s here and 2 NO3s here, which I can cancel out. There's 2 Ks here and 2 Ks here, which I can also cancel out. Meaning that our final answer is going to be Pb, and then don't forget the +2, aqueous, because you can't forget the state either, plus 2I, negative aqueous, creates PbI2 as a solid, lead iodide. This is your final answer. Okay, so now I want everyone else to get like a paper and a pencil out because we are going to be doing this next problem together. Now, this problem says calcium chloride, which is an aqueous state, plus sodium carbonate, which is also an aqueous state, creates what? So my first step is I already know to write my balanced molecular equation. So I'm going to first, I know that calcium is a positive, chlorine is negative, sodium is positive, and then carbonate is negative, meaning that the positive is going to take the negative and vice versa since this is a double replacement. So calcium is going to take carbonate, so CO3 plus the NaCl. I know anything with a carbonate is always going to be insoluble, which means that this is going to perform a precipitate and be a solid. And then NaCl is usually soluble since it is part of the alkali earth metals. So this is going to be an AQ. Now let's see if it's balanced. No, it is not balanced. I have to give NaCl a coefficient of 2. Now that it's balanced, I can start to write my ionic equation. How do I do that? I need to split up all of my reactants and products that are not solids. So just my like aqueous solutions. I'm going to split this one up. I'm going to write calcium, which is Ca plus 2. And then, which is an aqueous state, plus chlorine, negative aqueous, plus 2Na plus aqueous, plus a carbonate, which is CO3 negative 2 aqueous. And then this all creates, again, if I have anything that's a solid, I always leave it. So I'm not going to split up my calcium carbonate, solid, plus this, and then plus 2 Na positive aqueous plus Cl negative aqueous. Okay, now that I've written my ionic equation, what do I do now? I need to cancel out all of the ones that I see that are repeating. Well, I see 2 NAs that are repeating, see Cls that are repeating, and that's it. Meaning that I can just, my last step is to just combine what else remains. So my final answer is that calcium, which is plus 2, aqueous, plus carbonate, which is CO3 negative 2, aqueous, yields calcium carbonate, which is in a solid form. That is your answer. Thank you guys so much for watching, and I'll catch you in the next one.